In our last lesson, we learned how Python stores information using variables as labels. Today, we are going to learn about what kind of information Python can store. In our daily lives, we are surrounded by different kinds of stuff. We have solids, like a rock or a piece of wood. We have liquids, like water or fuel, and we have gases as well. Each of these has its own properties, and you need to know how to interact with them. You can't hold air in your hands the same way you hold a rock. The way you handle a liquid is different from how you handle a solid. Even within the same group, things can be different. Water and fuel are both liquids, but you must handle them very differently. In the world of programming, we have the same concept. We deal with different kinds of data, and Python needs to know what type of data it is, so it knows how to handle it correctly. The most fundamental data types are numbers and text. And just like the difference between water and fuel, even within the number category, we have different types that we need to handle differently. Whole numbers and numbers with decimal points. This concept is called data types. Python has several built-in data types, but for now, we are going to focus on the four most essential ones. Integer. This is for whole numbers, both positive and negative, without any decimal points. For example, 10 minus 5, 0. Example like saying, I have 3 cars. You can't say I have 3.5 cars. Float. This is for numbers that do have a decimal point. The name float comes from floating point number. For example, 9.81, 3.14 minus 0.5. Example like saying I weigh 70.5 kilograms. String. This is for any sequence of text. To tell Python that something is string, you must put it inside quotation marks, either single or double. For example, hello Sarah or hello Sarah between single quotation. 1, 2, 3 between double quotation or single quotation. A very important point. Even if a string contains numbers like 1, 2, 3, Python treats it as text, not a number. You cannot do math with the string 1, 2, 3. Boolean. This is the simplest data type. It can only have one of two values, true or false. It's the language of logic. Example, as the answer to the question, is the door open? Which is simply yes or no. Okay, let's see these data types in action in our workshop. I will create a new file called lesson4.py. Let's create 4 variables, one for each data type we just discussed. For example, age equal to 30. This is integer data type. For example, pi value. In mathematics, we have pi is equal to 3.14. Name, for example, Hama between double quotation. It is a string. Is programmer equal to true, a Boolean type. We have created these variables, but how can we ask Python what type of data each one is holding? Just like we used the ID function to see memory address, Python gives us another powerful built-in function called type. The type function tells us the exact data type of any variable. Let's try it. Print type age, for example. Print type pi value. Print type name. Print type is programmer. Let's see the results. Look at this. The type function confirms everything we learned. Python knows that age is an integer, pi is a float, and so on. This is how Python knows how to correctly handle our data. But why does this matter so much? Let's look at a final. Critical example, what happens if we try to add a number and string? Let's say num1 equal to 10, num2 as a string equal to 5 between double quotation. Print num plus num as a string. We get an error, a type error. Python is telling us, I don't know how to add an integer and a string. This is like trying to mix oil and water. They are different types, and you can perform the same operation on them. This error is not a bad thing. It's Python protecting us from making a logical mistake. It's focusing us to be clear about what we want to do. This is the fundamental reason why data types are so important. They define the rules for how we can interact with our data. In our next lesson, we will dive deeper into the most common data type you will work with, the string. And now we come to our final fundamental data type, the boolean, or bool for short. On the surface, this is the simplest data type that exists. It can only have one of two possible values, true or false. That's it. Nothing else. But do not let this simplicity fool you. The Boolean is one of the most important and powerful concepts in the entire world of computing. Think about it, even in our own natural language. The simple words yes and no are the keys to massive processes. They are short expressions, but saying yes can be enough to start a huge process, and saying no can be enough to end one. Consider that. A general asks their commander, do we launch the attack? The answer is either yes or no. A single word can be change history. The electricity for an entire city can be controlled by a single master switch. That switch has only two states, on or off, true or false. In the world of programming, Booleans have that same level of power. They are the backbone of all decision making in our code. Every decision a computer makes ultimately comes down to one of these two values. Did the user enter the correct password? Has the player collected all the coins? So true and false are not just words. They are the on and off switches for our programs. They decide when to start a process and when to end one. In our upcoming lessons, you will see how we use this simple data type to build incredibly complex and intelligent logic. Why do we even need to know about data types? To answer this, let's look at something we all see every day, an online forum. Take a look at this forum. Each field asks for a different kind of information. For example, full name. Here, the computer is expecting text. In programming, we call this a string. Gender. This is a choice between two options. It's a yes or no question. In programming, this is a Boolean, true or false. How many cars do you have? You can't have two and a half cars. The answer must be a whole number. We call this an integer. Your y in kg, in kilograms. Here, your y might not be a perfect whole number. For precision, we need a decimal point. We call this a float. Your phone number. This is a very important point. It looks like a number. But do we ever perform math on a phone number? Do you add your phone number to someone else? No. When a number is not used for mathematical operations, we often store it as a string. Upload image. This is a more complex type. Images are stored as a binary data, a series of zeros and ones. Your favorite color. Colors are often stored as a special text code called a hexadecimal code. For example, hash 00FF00 for green. So what's the takeaway? Even in a simple form, we deal with many different types of data. The computer must know the type of each piece of data to store it correctly, validate it, and work with it properly. This is why data types are the absolute foundation of programming.